So I found a really interesting equation today. So I wanted to discuss it. If you see e to the power x is equal to 0 has no solutions. You can see it by the graph of y equal to e to the power x also. E to the power x never reaches 0. But now if we see e to the power x equals to 0, this equation, it does have solution. What's the catch? First, if you see, if you take ln on both sides, it simply reduces to e to the power x equals to 0. So if e to the power x equals to 0 have no solution, so how this is having solution? First, I will prove mathematically the solution of this equation. Let's see. So we have this. Now I will use the polar form of complex numbers. So this is the polar form for reference. So I will write 1 as 1 into e to the power I 2 pi t, any multiple of 2 pi as a theta. Now I will not explain the polar form here because I am assuming that's a prerequisite. So now e to the power x equals to this 1 into e to the power I 2 pi t. From here I can write this as after taking ln on both sides, this will reduce to e to the power x equals to this. After that I am writing as into 1, and again I am writing 1 as e to the power I 2 pi t2. Now someone can take ln here also on both sides, but that will not help you solve the equation. I have tried that path. So I have tried this technique. You need to do something unique here. This is a unit kind of equation. So into 1 into e to the power, again I am writing 1 as e to the power I 2 pi t2. Here I am taking t2 as a variable. Now taking ln now on both sides, you will get x is equals to this ln of I into 2 pi t plus ln of e to the power I 2 pi t. Okay, now you know the property of ln a plus ln b gets multiplied. So this is multiplying first part, second part, so I am separating it. These are basic techniques. So now x equals to ln of this plus 2 pi t2. Now here t and t2 are integers obviously, and t cannot be equals to 0 because then this will be not defined if t becomes 0. So for that we have to take that account, and since t and t2 is integers, for all the integers of t and t2, t not equals to 0, we will have a solution x. So let's try one for sake of proof. And let t and t2 equals to 1, so x will become ln 2 pi I and plus 2 pi I. So now I'll put this x value in the expression, original equation, that is e to the power x equals to 0. So e to the power x equals to 1, sorry. So now I'll solve it. After that, just separated the plus sign e to the power a plus b, you can separate it as e to the power a into e to the power b, basic identity. After that you will get this e to the power 2i pi. So again we know that e to the power 2i pi equals to 1 by the polar form. I have used it in the first step only. After that this is 1, so this again e to the power ln of 2i pi, this will again reduce to e to the power 2i pi. Ln and e will cancel out. Again we know by polar form that this is equals to 1, hence this is equals to 1. So hence this is a correct solution, and also if you can try with other integers also, this is only the same thing. So yeah, I don't know how I can explain this, that what's interesting to me is that this is reducing to this and this doesn't have a solution, but this has a solution. If somebody has the explanation of that, please do comment.